In this tutorial, I'm gonna walk you through the assembly workbench and how to insert parts and constraints and how to create simple and exploited assemblies along with the tips to avoid the conflictions and errors you might have to deal with. In computer-aided designing process, an assembly is a process where you combine all the individual parts into a single model, and it represents how they fit and how they move together in real life. And as you can see on the screen, assemblies are essential for designing mechanical systems, machines, and products made for multiple components. In FreeCAD, you can use the assembly workbench to work with these different parts and fit them all into one single unit. And in the figure 12, that's a jet engine assembly. So that is pretty much how an assembly would be in the exploded view. So first off, I'm gonna start off by creating a parametric part. And I'm going to select the assembly workbench. Go to the model. You just have to create a assembly first, and it will be appeared in the model. You can see it right over here. So basically, first we have to work on our body. For the simplicity, I'm going to choose FreeCAD primitives. I click on additive box. You can see our box over here, and I'm going to click OK. I'm going to create another body. I'm going to add an additive cylinder. The attachment tab, you can see it's selecting, so we have to select the plane. So I clicked XY plane, and I'm going to move it along the X direction. I can click OK. You can see that both objects are in the viewport. I'm going to insert both bodies into the assembly workbench. And now both bodies in the assembly workbench, so you have to select or double click on the assembly to enable the assembly workbench. You always have to set a ground to one of the objects. So I'm going to select this cylinder. Alright. Now these are the constraints that you can apply to the objects you have here. The first one is the fixed joint. As you can see, it already got fixed into the cylinder over here. You can use any of these surfaces. You can set also an offset. Let's just click OK. So now we have the revolute joint, create cylindrical joint, create slider joint, and ball joint, distance and parallel joints. So these are the joints, and they create perpendicular. And most of the time you'll be working with the first 4 joints. Over here you can see I have probed some of the solids into the viewport. I highly recommend you watching the previous videos in this series, so you'll definitely have an understanding of how to create these solids. And also I have renamed them for the ease of use. For now I'm going to hide these flat bases and also the gimbal. To demonstrate the rest of the joints, I'm going to first select this nut. We toggle the assembly and I'm going to show you how to use the revolve joint. So you simply click on the revolve joint and select the base or anywhere you like in this nut and click this hole. You can see the nut has been fitted into the hole. And I'm going to change the navigation style into Blender. And now if you try to rotate the nut, it will respond by motion, and that is because revolve joint allows you to rotate an object along a single axis between the selected parts. Over here you can also try changing the type of joint, and now I have selected the cylindrical joint. So as it appears here, it enables rotation along one axis while permitting the movement along the same axis between assembled parts. So put that into perspective, you can slide the nut along the hole while also rotating the nut. And next up we have slide joint. So it only lets you slide the nut along an axis but not permitted for rotation. However, you can use limits like the minimum length, maximum length for precise controls. I have set the maximum length to minus 10.26 millimeters. And you can see it only went down to that level. Now I'm going to cancel. And now I'm going to hide these two nuts. I'm going to bring back the gimbal for their demonstration for ball joint. So I'm going to click on the ball joint. I'm going to select the base of the gimbal we created over here. Let's reorient the model. I'm going to select this base. So this is basically how the ball joint works, and it basically allows you to move the object without restrictions as long as the joint remains in contact. Okay, and I'm going to cancel this. And I'm going to demonstrate how the other joints work, such as the distant joint, parallel joint, and etc. So make sure to set the ground for one of these spaces. And I'm going to use the distance joint. And I'm going to select this surface. And this surface. Let's go to the advanced offsets. So you can see when you adjust the translation, it responds accordingly. Let's click. Let's try changing the type of joint to parallel. And if you again translate, you'll see now it's in parallel mode. Just cancel it. And next up, I'm going to demonstrate and next we have the perpendicular joint. I'm going to select this face and this face, click OK. You can see this second flat base is positioned perpendicular to the other base. You can also try adding some offsets along whichever the axis you want. As you can probably guess, this is a piston. I created these separated parts. Crank, the piston nut, and connecting rod. I'm going to show you the sketch I've used the piston. Just basically draw this and use the revolution. Created the hole using the bucket and also the crank, connecting rod. This is a catch of the connecting rod. This is pretty much similar to the yoke link from our previous tutorial. I highly recommend you watching those videos. And I'm going to close this for now. So this is the crank. I'll show you a sketch for it. For all these parts, I'm going to create an assembly, and I'm going to move all these parts into the assembly folder. You can use the Control and Shift button, click on every part and move them inside the assembly. And you can also import parts into the assembly using this feature like this. You can click and it loaded into the insert component box. For now, I'm going to delete that. I have hidden the crank nut. I'm going to set the ground to the piston. You can use this toggle ground option. So basically, ground apart. You always have to ground apart in order to allow the joints to be included in the assembly. Here I have used a revolute joint. I'm going to click the crank nut. We have to do a little bit of work around here. So I'm going to connect the piston nut and set the angle to 90 degrees and X to 90 degrees as well. Okay, now it's in perfect position. I'm going to apply the revolute joint also into the connecting rod and the piston nut. Perfect. And you just click OK, and now you can select the navigation style of Blender and rotate this along this axis. Okay, now I'm going to bring the crank into the viewport. Let's bring the crank nut. Alright, so I'm going to design it with a revolute joint, and I'm going to select the center of this nut. Now the bottom part, and design it with the one side of the connecting rod. It's also in the perfect position. I'm going to change the navigation into Blender. You can see this, it also rotates along this axis. Now we're gonna bring in the crank. I'm going to apply a revolute joint into this as well. Just click the center of this hole. And the nut above here, I think it's just went right through it. Let me undo it. Let's select the edge of this crank and about here. right in, now it's in perfect position. Alright, let's reorient the model a little bit. So let's click on OK. Let me change the navigation setting to Blender. Now you can rotate this crank along the crank nut, just like this. You can also rotate the connecting rod along the piston nut. So both are the two axes that the crank and the connecting rod will have their rotations. So that's pretty much how you create a piston assembly and apply those joints for rotations. Alright, now I'm going to show you how to create the exploded view in this assembly, which is head over to Assembly Workbench. And you can see this icon here, create exploded view. You can click on explode radially. You can choose an axis and just drag this out, and you can see all the parts are dissolving from the main unit. Alright, I'm going to show you once again. You can just click OK. You can see the exploded view over here. Alright, now we have come to the end of our video tutorial. We hope that you have learned something new from this tutorial, and consider subscribing to our XIVIX University channel and turn on the notification bell so you will be notified when we post our next video in this tutorial series.